Okay, thank you everyone, and thank you IBCAST organizational team for this talk. And sorry for my heavy voice because it's too early here. It's just 6 a.m. and I hope, yeah. So my name is Jamal Abdul Nasir. I'm currently working as a research fellow at Data Science Institute. It's in National University of Ireland, basically. Uh, I'm also affiliated with International Islamic University, Islamabad. And formerly, I was engaged with RMIT and some other universities like TU Darmstadt and HUA Athens. And current research includes my area of interest is data science, blockchain, knowledge graphs, and linked open data. You can see my publications and other materials by searching on Google Scholar. So today's topic is about blockchain and its application and like more specifically some use cases from software engineering field. And then at the end, I will discuss my current research that I'm doing in blockchain. So can you guess what would be the price of these two pizzas uh, 10 years ago and now? So like this is the prior actual picture of two pizzas that were bought 10 years ago. But there is a big story behind this picture, and we usually call it as a pizza story. So it's an infamous pizza story. So it started in 2010 when one person asked online that can someone bring me two pizzas and I will give him or her 10,000 bitcoins. So, so yeah, it's just 10 years ago. So he was offering 10,000 bitcoins for these two large pizzas with some onions and all the stuff he was mentioning. And even like after 3 days, there were no person, no one was willing to provide him uh, pizza for like 10,000 bitcoins. So, but on the fourth day, one person got pizza, and so they traded for 10,000 bitcoins. So yeah, so he put pictures. So this pizza picture is actual picture of that two pizzas that he bought in terms of 10,000 bitcoins. So after 4 days, he was successful to trade 10,000 bitcoins for two that pizzas. So obviously at that time, that cost of that 10,000 bitcoins was just 41 US dollars. So we can say that this pizza, one pizza cost would be $20. But if we convert that 10,000 bitcoins, so actually after 10 years, the cost of this pizza is 330 million US dollars. So I don't think we uh, or anybody have ever uh, eat such expensive pizza. Like after 10 years, its cost was 330 million US dollar or 115 million US dollar per pizza. So yeah, so so my topic is about this thing. It's not actually about bitcoins, but it's about blockchain, the backend technology that is supporting or um, uh, Bitcoin. So let me start from here. Yeah. So basically, when in 1990, we know that HTTP was formed, and obviously there was some protocols and all the stuff. So whenever there was some new technology or new research emerged, then we got some very good companies exploiting these technologies. Like for Amazon, 1995, it was created in 1995 because of HTTP or internet thing in 1990. Similarly, Cisco uh, is all of you know that Cisco is networking solution providers. So this is because of TCP/IP thing in 1974, and then Cisco was formed in 1984. Similarly, 3Com um, is also a network related company, but it was hired, I think, yeah. So it was acquired in 2010 by HP. So, so, so whenever there is some new technology, new technological giant or new technological company has emerged. So similarly, so because of internet and in 1994, uh, so some people say that pizza was the first online sale, which was done by Pizza Hut company. And so in 1994, it was happened like on the internet, people could order pizza online and all the stuff. Although at that time, uh, they don't have any online payment facility, but they use cash on delivery thing for that pizzas. So this could be because online transaction and payments is not like why it was not possible at that time because of that security and all the stuff, and these things are not so much available. So that's why there are so many cryptographic digital currencies that were failed in 1989, in 1993. These are the few Mondex and DigiCash and CyberCash. These are the few early cryptography digital currencies projects that were failed because we will know that why they were failed. So, but when in 1996 that's SSL and TLS was introduced, these are secured socket layer protocols. Then we know that in 1998 PayPal was formed, and because of this SSL and secure and all the stuff, it it could be possible that people can transfer amount from one person, one point to other point, without compromising their credit card informations and other stuff. So, but yeah, even after that, SSL was formed in 1996 or something. Even after that, there was many cryptographic digital currencies were introduced, like Hashcash, Bitgold, B-Money, and other stuff. But all these uh, cryptographic digital currencies were failed. So, so after 10 years, like because this riddle remains like how to move value peer to peer without any trusted central intermediary. So this is the main problem, that like how we can transfer money or how we can transfer files. Here I am just uh, as I told earlier that I am taking this Bitcoin as just as an example, but you can consider any file to transfer between two people, or it could be any music file, it could be any secret file, it could be any file or anything, any data, so which is precious for you or the other party, but you don't want to get compromise of it. So yeah, so the main problem of this thing is the internet, because internet relies on central um, one server or centralization. So obviously you have to trust that central uh, mm, service providers or something. So, but this problem was the main issue, that people cannot use or are not able to use that online transfer things securely, because security can be compromised, that content can be changed, or even that central service provider can change its um, mm, values or prices or all the stuff, right? So these are the problems with central thing. So, but in 2008, uh, we got an email from Satoshi Nakamoto. That person is behind Bitcoins, and that uh, that person is still unknown to the world. So we don't know uh, this is a one person or one team, one company. We don't know. So there are many speculations about him or her, but it's a just a fake ID or fake name. But that person claims that like I have been working on a new electronic cash system that's fully peer-to-peer with no trusted third party. So then he launched Bitcoins in 2009 and all the stuff. So basically, from the open layers, we can see that like when in 2009 that Bitcoin concept was introduced, like it's a programmable sort of thing that through programming, through software, all the things could be managed. Then that blockchain mm, technologies emerged. Uh, yeah. So what is a blockchain? So blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. So these are the two, three things that people were asking. So this is the one of the main reason behind blockchain thing. So, so blockchain is a digital ledger of transactions that is duplicated and distributed across the entire network. Okay, so most of you know that in computer systems or in computer networks, we have server-based applications and we do have P2P applications, so peer-to-peer applications. And this blockchain is like uh, one of the type of P2P applications, obviously, but this P2P concept was not new, and it was people were using like or know that that concept uh, like 20, 30 years ago, even before that blockchain thing. But the problem with P2P or central thing was that like security, one of the problem was security, because and similarly anyone can change files or so it can be compromised. So blockchain enables this thing that people cannot change the added things, and obviously security and transparency, a transparent thing. So this is the blockchain. So yeah, even in the figure, if you can see that in the figure, like if someone requests a transaction, we have to like yeah. So that block could be added in the network of nodes and all the stuff, and it would be once verified, and it would be become permanent part of it of that network, and then it accessible to everyone, and obviously no one can change it, or if there is some changing or if there is some corruption in that content, then it would be everyone know that this is the not original content. But on the internet, you can say you can see that people can put any data and can claim it that it is the actual data, but obviously there is no check on this thing. But this is not possible in blockchain. So I will quickly, okay. So these are the properties of that digital ledger technology that blockchain is using, or these are the actual properties of blockchain applications. So they are programmable, uh, they are secure because they are using asymmetric encryption, and that public and private keys, that asymmetric encryption and algorithms, and similarly hash functions. And obviously it's distributed just like P2P applications, and anonymous. Uh, you can hide your identities from the participants, and time stamped, like when it was added to the system, and immutable. Okay, so no one can change your content. This is the important property that blockchain holds. Like if you have some data or something that you have added to the blockchain network, then it will become immutable. You cannot change it. So immutability, once added, then content cannot be changed. So decentralization, obviously we don't have any server, we don't have we don't have any central controlling power which can censor our content or which can delete our content. It's not possible, because in decentralization, like if you have like Google search engine, they can add your links, they can drop your websites, or they can put conditions and all the stuff. But once all the systems are peers or nodes, no server, it means that there is no authority is vested in one server or any other machine. So security, obviously asymmetric encryption and hash functions are using. We will discuss hash functions and all the stuff later on as well. And then transparency. This is important because you cannot delete data, you cannot change the contents of data, you cannot change ownerships and all the stuff. So it means that the data, the blocks or data is very transparent. The process is very transparent. You know what happened 10 days ago, what happened 1 year ago, or what happened when it was added to this system. So this is transparency. So we have two types of blockchains, public and private. Obviously, as the name suggested, in public, people can, anyone can join and get data and all the stuff. And but in obviously private blockchain, you have some restrictions, member control, who could be part of that private blockchain, or and then obviously you can mm, because of this, energy consumption is good. You can decide or have consensus of using different. Um, you can say that like resources utilization could be better in private blockchain because you have consensus. People or members would have consensus what they will use. So there are so many applications of blockchain, like secure sharing of medical data. Medical data is very critical because it do contains uh, history of patients and all the stuff. So they're sharing between two hospitals or between government organizations is very critical, especially in Europe or in other countries, US or Canada, and even some other countries as well, like where they do care about the privacy of patient and all the stuff. So if you want to share that medical data over the internet, you must have some secure mechanisms. So blockchain, a lot of, there are so many applications people are building in medical data sharing applications. Similarly, music royalties, tracking, cross-border payments, real-time Internet of Things operating systems, personal identity security, anti-money laundering tracking system. So these are the different applications, and because most of the participants of this conference are students, so if you want to explore blockchain and specifically with some particular task, then these applications could be a very good starting point for you to start thinking about that how in your particular task how blockchain can be implemented. So it could be a good research area because this technology blockchain thing is very new as compared to the other established technologies of computer science. So these are the few applications: supply chain and logistics monitoring, voting mechanism. Uh, just remember that the benefits of blockchain. So if you like, if you have 3 4 benefits in your fingertip, like uh, number one benefit was like immutability. You cannot change your data, or any others, anyone others, yeah, other one, even someone else cannot change your data, and you cannot change someone's data. So immutability, security, decentralization, and the fourth one is transparency. So these 4 are the main properties of any blockchain application. And so you can take any task in which you need some of these properties or all of these properties, then blockchain solution would be a good um, solution for that particular task. So if you want security, if you want immutability and all the stuff, then so that's why there are so many applications of blockchain: voting mechanism, advertising insights, original content creation, cryptocurrency exchange, and real estate processing platform. So so these four these are these four are the benefits of blockchain. These four are, so if we take these four benefits and compare it with the needs of cloud computing, so we will know that cloud computing do need that thing, right? So in cloud computing, these are the basic requirements nowadays. So that's why there is a very good merger of blockchain technologies and cloud computing nowadays. There are so many companies that are that were providing cloud computing solutions, but now they are also providing blockchain-based cloud computing solutions. So we call it as a blockchain as a service, and like mm, Amazon managed blockchain, Microsoft's Azure blockchain workbench, Oracle, IBM, and SAP is also providing. And I think uh, Samsung has also blockchain service provider as a SaaS. So yeah, so now uh, we can see one use case of software engineering and how we can use blockchain in software engineering. So blockchain technologies can solve many core software engineering problems like continuous integration, CI services, and package managers, right? So these two are very hot research areas and very useful areas of software engineering. People, most of people are working on it. Like uh, in continuous integration services, people do add or collaborate their code with others. They and then compile and all the stuff like GitHub. Uh, CI or GitLab CI. Travis is also open source CI. Similarly, package managers like in Java, Maven, or similarly, so apt-get and all the stuff in which details, all the details of installing or updating or running or deleting, uninstalling any software are is present in one package. So these are here we can use blockchain thing. Like in CI, I took this idea, so I'm just discussing another work. It's not my work. So let me, yeah. So yeah, you can read this paper, blockchain-based software engineering, and then these are the authors. And so they proposed CI, blockchain-based CI. So in blockchain-based CI, what they are doing is they initiating build transaction, and then this would be distributed to different peers, different nodes, and it will obviously second step would be scatter the build in the network, and then they will run different instructed CI jobs, and if they are successful, then they will report outcomes, or not successful even, they will report outcomes to peers and all the stuff they will exchange, and then after that, when it's successful, then it would be added to the blockchain. So by this way, we can use blockchain technology where people can collaborate and all the stuff. So right now, yeah, what I am doing right now is that like we are working on a project which is based on blockchain, and but it's for data set sharing in data mining, or in every field. You all of you know that that we do require a lot of data sets, and similarly in semantic web or linked open data, we do need different data sets. So right now I'm working in linked open data field or semantic web field, in which we have thousands of data sets that are distributed over the internet, but most of the time we these links were down because of central thing and all the stuff. So what we are planning or what we are proposing or working is that we are providing um, blockchain based file sharing systems. So here files are data sets. So in short, you can say that it's a linked open data sets. So why we are using this? Because if we have one central server which would be sharing thousands or 10,000s or 50,000 data sets, obviously it would put some infrastructure load on that server, right? So an increase in distributed services and data sets has put the infrastructure load in terms of availability. Yeah, this is a main concern because people like uh, what happened actually, like for example, we have some project funding for 2 3 years. We will buy some server, we will provide different data sets. But once that funding is ended, then that server would be down. Okay, so it means that now that data wouldn't be available to the other community, to all community. So this is the main issue in terms of in every field, you know that there are so many broken links, right? So this availability is related to broken links. So because that server is down, it means that you cannot download data sets or any other material. It could be uh, music files or movies or other important files. So immutability, this is the second problem that we are facing in terms of infrastructural load. Immutability is that like we don't know if I'm um, downloading someone's song, is it original or is it not original, or is it tampered, or it could be. So I'm not sure on the internet that if I am downloading someone's content, let's suppose someone sent me that this is the article of some very famous scholar or something, then I have to check. I have no um, source from where I can check that this article or this news or something is not fake. Okay, or might be 100 lines, out of 100 lines someone has added 20 lines in it and then call it as a article of a particular scholar. So this is a problem of immutability and security, obviously. Security, yeah. So in terms of availability, we have one linked open data cloud that we are maintaining here at NUI Galway. So these are the stats from that data set. This server, Lord Cloud server, that only 75% of the data sets were available. So out of 1,000, 1,400, only 1,091 data sets were available. So availability is the main issue. Similarly, with links, 59% are available and all the stuff. So what we did in this work, what we did is that like so there is one uh, LOD laudrement. Basically, it's a collection of zero point 0.6 million data sets. One person in Netherlands did this during his PhD or under some funding. But once then he set up a online server which could provide that zero point 0.6 million data sets. But the problem was that like after a few years when the funding project was over, he just shut down that server, and now that zero point 0.6 million data sets are not available to anyone. So so basically our research project is that we want that zero point 0.6 million data sets back available to all community in people working in linked open data. So this is a laundromat data set. So what we are doing is that like we are taking intersection of linked open data that we are hosting at NUIG. So and from there we found few thousand data sets that were common, and then we converted it into HDT format. And HDT format is just like, you can, if you don't understand, no problem, it's in RDF, or it's a link semantic web format. You can say that in PDF format or .csv format. So we converted into a smaller size HDT format, and then we added this thing to IPFS. So what is IPFS? It basically, IPFS is Interplanetary File System. It's a distributed system for storing and accessing files, websites, applications, and data. And obviously, it's backed by blockchain. So in IPFS, it's a content-based addressing instead of location-based addressing. Like over the internet, whenever you need some material, you have to provide its location, right? Like if you want to see some Wikipedia page, you have to go to www.wikipedia.com/Pakistan, let's suppose pakistan.html, right? You have to provide location of the particular content. But this IPFS, and because of this blockchain thing, uh, this is a content based addressing. Okay, so whenever you will add some content to IPFS or blockchain, you will get a hash code, or you will get a code for that content, and then everyone in the world can search your content on the basis of that hash code, right? So he or she does not have to provide like uh, exact location where that content is lying, or which computer has that content. No location based searching, just they have to provide a hash code of that content. So example is here, like if I want to search some Wikipedia material, then over the internet, I have to provide its location, exact location. This is a URL, URI. Obviously, all of you know that at the backend, there would be some IP address. DNS would resolve that Wikipedia IP address and all the stuff. And then web server would find out that particular page. But in IPFS, so you only have to provide that, uh, you can say that hash code of it. Like number 1 2 3 4 5 6 7 8 would be the number of that content that would be that was added to IPFS. So this is so by using this IPFS blockchain thing, we were able to generate new cloud of that linked open data. We called it, that's why we called it iCloud. uh, I is coming from IPFS thing. So this is a cloud, like we have like mm, um, so this is at your left, it's a basically example of one data set. It's all information and sparkle. And and can you see at the end of this left side, there is a one symbol IPFS, and there is a code QMRFC46YAN. Yeah, so this is big code. This is a hash code of this content. What does it mean? That if someone uh, will add that content in Germany, let's suppose, he will get similar code if the content is same, right? So it means that uh, we don't have any duplication problem in this scenario as well. But you know that on the internet, we do have duplication problem as well. Like people, if I like one song and 1 million people like that song, you can, might be 1 million people would be adding that song on YouTube or some other stuff, right? But due to this IPFS, duplication is not possible, because because the addressing is content based. And if you were uploading the same content, then you will get the same hash function. So yeah, so duplication problem could be solved as well in this case. So at the right, it's just a IPFS cloud of different data sets, how they are connected with each other, and they are available through IPFS. And it's very easy to use. You can install IPFS on your computer, and then by browser, in the browser, you only just have to add that thing, that localhost 8080 port and IPFS, and then this QMPUST is the hash code of a particular file. Obviously, you need some distributed or might be small central server where you can find hash codes of different files, just like yeah, so BitTorrents or and all the stuff. So we are, after this work, we are trying to enhance this work by taking that zero point 0.6 million data sets uh, that were in Laudroment and converting it into a blockchain um, format and all the stuff. And then we would have that zero point 0.6 million data sets available, readily available for researchers, people who who can use that data sets in their research. So I'm not sure how much time. Okay, I have taken a lot of time. So thank you very much. You can ask any question. And obviously, it's very difficult when you are not seeing that how many people are understanding or not understanding their face expressions. So anyway, thank you. Thank you very much.
Thank you very much, sir, for your talk. We have few questions. The first one is that cryptocurrency is getting popular day by day. So, what are your recommendations for someone who is interested in getting into it?
Um, Obviously, I'm not sure the question is about purchasing cryptocurrency or working research or doing research in cryptocurrencies. But obviously, I wouldn't say anything about purchasing or something. But obviously, uh, this field is emerging, and after 10 years or 20 years, all the governments or people would be using that cryptocurrency thing. So if you want to do like research in that area, obviously it's a very open research area, and you can excel very easily in that field. Yeah, it's a future. Like in my talk, I told you that like if only 10 years ago in 2010 that two pizzas were just 10,000 bitcoins worth, and at that time it was only $40. So you can see that jump, that $40 to 330 million US dollars. So you cannot compare or you cannot predict that thing. But obviously, after 10 years, things would be more clear. And uh, I can say that obviously blockchain is a future, yeah, prospects, has future prospects. Yeah.
Okay, sir. Now, Dr. Usman, we would like to ask few questions from you.
Ji, Dr. Jamal, thank you so much for your nice talk. I have like a few questions, but first of all, I would like to go to this environmental energy use of using like this blockchain technology, because when we talk about scalability of blockchain, there is a cost associated with it as well. So some businesses or some organizations can deploy this thing, but it's not like everyone can use it. So can you shed light on this thing, please?
Actually, because blockchain there is a award mechanism thing, and it's a like similarly to peer-to-peer applications. If there are there are not so many nodes that would be sharing their power or their hard disk and all the stuff, then obviously this system could not work, right? So that's why in that initial cost or initial thing is high. But I think with the passage of time, when people or when more companies or when governments would realize the potential of blockchain, then definitely these blockchain solutions would be like more affordable for smaller companies as well. So right now, this is a inherent problem with peer-to-peer applications. You remember that, like uh, in BitTorrents, if you are not sharing your movies or files that you are downloading, obviously, then your connection would be slow and you wouldn't be get more fast torrents. So obviously, you have to pay back in terms of your RAM or in terms of your hard disk or your resources. So yeah, that's why initially it's expensive.
All right. So my second question is regarding like because you said like file sharing thing. So there's always one thing which comes up is the copyright thing. So what do you say about that? Because copyright can be violated when we like everyone is connecting peer to peer as a decentralized system.
Yeah. So, but yeah. So basically, this is one of the solution. This is one of the problem with P2P applications. Yeah, that's why we know that there are so many P2P servers like Nutella and Nipster and all the stuff. They were blocked or banned in US and all the stuff because of this copyright violations. But I think, but in blockchain, you cannot control the things as you want, but at least you can propagate very easily that this stuff is copyrighted, because that content cannot be changed, right? So you can easily find out that, like, oh, this file which was uploaded by someone, but this file, you can mark that file easily that this is a copyright violation, because contents and all the stuff, right? Like for example, on the internet you can deceive copyright servers by putting files in zip file or csv file or something, not csv but in zip or some other thing, or adding some extra video with it or something. But yeah, this copyright solution is still an open problem in blockchain as well. But that transparency power property of blockchain, I think, would help to find out all the traces of that file. If that all traces, because trust is also a main factor in blockchain. If you don't have a trust with the other party, then obviously this would degrade overall system. And if one party is sharing um, mm, copyright violation files or all the stuff, then obviously it's his trust would be down. And once trust would be down, you can make any policy over the blockchain system that so ultimately that company will go down. Yeah. If no one would be trusted, then obviously no one would be accessing it or providing access to their contents.
Yeah, thank you so much, Dr. Sam. And one thing is like, yeah, we all know like AI and blockchain are a perfect match for each other. And like our audience and like, the students who are going to use blockchain with AI, it can make a lot of sense. But one has to be very careful, like where one can use blockchain because it has associated, like as you said as well, like the cost associated with it when you talk about scalability. And what about regulations? Because when we talk about blockchain, there's no central body. So how one can manage as a on a country level? Because there was a question I can see, like someone has asked, like in how many countries this blockchain is being deployed. But I believe government is most of the times is mostly worried about this regulation thing. So what do you say about that?
Yeah, that regulation thing is very important, obviously. But again, uh, I think the main power of this blockchain is freedom. Like there is no central body which would be controlling it, right? But there are some algorithms, mechanisms that do provide trust base or some other regulation based thing. So main thing is reputation, and obviously if if government and all the stakeholders uh, like if they think they can come up with some regulations or some algorithms that can control many things in blockchain. But right now obviously because government or some other institutions are not putting their efforts or resources towards blockchain thing, then people or companies like if Microsoft or if SAP or Oracle and all the stuff they are investing in blockchain, it means that they know that one uh, today, if not today, then tomorrow or the day after tomorrow, governments would be agree about this thing. So I think blockchain has future. That's why all companies, Samsung is investing millions of dollars in blockchain technologies. Amazon is already investing. Every IT company, Google, and yeah, so everyone is looking for solutions based on blockchain. So and as you said, obviously we cannot apply. Um, every task not every task in every task we cannot apply blockchain, right? So I heard uh, in another talk that we cannot apply deep learning in every problem. Same is the case is that like we cannot apply blockchain in every problem. So if I know blockchain, it doesn't mean that I have to apply it for 2 plus 2 thing or apply deep learning for 2 plus 2 thing. So yeah, so
Sir, there is another question that many cryptocurrencies have been introduced that use blockchain technology. So, how Bitcoin has an upper hand as compared to Dash, Litecoin, and others if they all use the same blockchain technology?
so basically okay, in the start of the presentation, I said that I am do mentioning that like Bitcoin thing, but I'm not interested to discuss that Bitcoins and cryptocurrencies and all the stuff, they are legal or not legal, and why they are up and all the stuff. But the nutshell is that like because Bitcoins are the pioneers uh, in blockchain thing, and they have like a group of people or group of companies, unknown companies, right? So that's why people are investing in that thing. So if, like of like 10 years ago, no one was trusting on Bitcoins, but after 10 years, things have been changed. So it happened, it do happen like uh, for people or companies. Uh, so it's just a starting point. So whoever start first, any good solution, because it's providing solution, like it's not, uh, so whoever will provide it, obviously it will get first position or something. So this is a main reason. Like all other new technologies that people are using for it do have the same capabilities of Bitcoins and all the stuff. But because Bitcoin was old, because of Bitcoin, people do know about that thing, what is cryptocurrency. So whenever you call it, might be you can ask someone about cryptocurrency. He says, no, I don't know cryptocurrency. But when you say Bitcoins, they will say, yeah, I heard that word Bitcoin. So, so similarly, like Google search engine and search is just people know that it's Google search engine.
Thank you very much, sir, for your time and this detailed and informative discussion on this topic. And I hope that everyone has learned a lot after listening to your talk on this topic. Thank you very much, sir, for joining us.
Okay, thank you. Thank you, everyone.